In this video, we're going to look at how to graph an inverse function. Actually, it will work for graphing an inverse relation too. But this one we know is a function right here, so I've already drawn a function. If you're going to write this example down, try to be specific about the points. I put 5 specific points on. So my function goes through 0, 0, goes through 2, 1, and it goes through 3, 3. And it also goes through -2, -1, and -3, -3. Okay, so this is my function f. What I want to do is graph f inverse. Okay, so we know that, by our definition of inverse, if f at a were equal to b, that would mean that f inverse at b would be equal to a. Right? Whatever a goes to under f, f inverse takes back to a. So think about points, right? So think about this point. Let's think about this point 2, 1. We know that under f, 2 goes to 1, which means that under f inverse, 1 would go back to 2. So 2 goes to 1 means that the point 2, 1 was on our graph, correct? We saw it here, 2, 1 was on our graph. But if 1 goes to 2 under f inverse, then the point 1, 2 is on our graph. Let me use a different color. So 1, 2, this point up here is on our graph. So we kind of think of as this point is now this point. What other points do we have? We also had the point, 0, 0, right? So if 0 went to 0, well, f inverse would take 0 back to 0. So 0, 0 is on both graphs. 0, 0 is on both graphs. Same with 3, 3, right? If 3 went to 3, then 3 is going to go back to 3. So this point is going to be on both graphs. I'm going to try to do this without writing it down over here, but -2 went to -1, which means -1 is going to go back to -2. So -1, -2 is going to be on a graph. Basically, we're just switching x and y. So -2, -1. Maybe I should have labeled this one up here as 1, 2. And then similarly, -3. -3 is going to go back. So basically, you're just going to take all these points here and just switch the x's and y's. What you're going to end up with is a graph that looks something like this. So this red one would be f inverse of x. Basically, a good way to think about it is, and this is basically what we said here. If AB is on f of x, then you just switch x and y. So BA is on f inverse. So that's how you can get the inverse, just by switching all the x's and y's. Another way to think about this, notice there's sort of symmetry here, and that symmetry is along this horizontal line. And the equation of that line is the y equals x line. So what you could write is that you can get the graph of f inverse of x by reflecting the points on f of x in in the y equals x line. Okay. So this point was reflected sort of in this line. This point was on this line, so it just stayed. Same with this one, same with this one. But this point again was reflected. And then each point here was just reflected in this line. You can go point by point and just flip the x and y, but really that's what we mean by reflecting it in the x equals y line. So that's how you graph an inverse.